fortune. It's a book that was created in the 1800s, a Scotsman called John Napier.
I guess the one thing I'm looking at that has this kind of, I guess, work in 3D, so that's probably, it seems that the lower the dimension, the better things work. Some nice sort of speed up properties and so on. Oh. And we're looking at kind of the short term thing, and in the simple case, what is the average value of the first coordinate? Full degree of freedom from -1 to +1. In mathematics, I am interested in manipulating data and working with data and being able to do complicated calculations that are predictable and repetitive, and these sorts of things AI is potentially extremely helpful for. But there's another aspect. In order for mathematics really to be mathematics, it has to operate at the level of kind of logic and reason. A billion examples that something is true does not make it true. And this is a distinction that AI hasn't really been able to cross yet. The fact that it relies on data means that it's not as readily able to make generalizations that are completely true in all cases.
Alan Turing came up with the first test for intelligence, where he came up with the imitation game, where if in typing, conversing with a machine, you were not aware that it was a machine, then it was effectively intelligent.
Even simple things are not so easy, and certainly
verification and stuff on really critical stuff.
Yeah. I don't know how it does it, but
you can prove it. Like basic stuff about p-adics and p-adic numbers in Lindon. So AI is not going to replace me in the short term because AI still can't reason. So the difficult, effortful thought that we do as mathematicians do every day, AI still cannot do very reliably.
And calculators, and you set your numbers on these. And it's a Burroughs adding and listing machine. It has a little printing device, and it would be. The mathematics, the logic is now applied, if you like, computational logic and algorithms are applied to all problems. So it's not really the calculation anymore, it's computation applying itself to everything.
We'll carry on where we left off. So we were looking at unconstrained. Starting point to how we might approach this problem is a classic kind of first attempt at an optimization algorithm. About it is when I derive that the negative gradient is the right direction. The gradient change is bounded by a constant, which is... One place that I think AI would really struggle to work is maybe what comes next, kind of the, let's say, the aesthetic element. Is this a good thing to be talking about? Mathematics deals in the abstract. These concepts don't really exist in reality. So the question is, why do we care about the ones that we teach and research, and why do we not care about all the other ones? And there's a certain aesthetic sensibility, perhaps particularly in pure mathematics, that makes it closer maybe to the creative arts. And there's a judgment aspect, and I think AI is not really well designed for that sort of task.
Okay, yeah. And then there's this really... Another example. Could be this one. This is just linear.
Oh, right.
So it's linear map. If I'm using a computer in traditional computational way, I know what it's doing. And so I can say, okay, if it tells me the answer is that, I know why. It's performed the following computation. So all the steps are followable. Whereas often in modern AI systems, you cannot put your finger on what exactly it's doing. No one can explain what ChatGPT is doing, how it generated an answer. It generates an answer which is meaningful for us, but it's very difficult. This is the question of explainability, which is a massive issue. This theory, and then it turns out, as you prove, that there's a unique tetrahedron.
Yep.
And then a tetrahedron can be put together to make a fourth. I find it both exciting and tremendously worrying at the same time. I feel like there's this big wave coming for us, and we've got no idea what's going to happen. I think that we definitely need regulation, and we need to have a discussion about it as a society. I don't think it's good that discussions are being held in open AI boardrooms and things like that. I think that we need a discussion across society about how we want this stuff to be deployed, how we want to use it. It has enormous potential, but I think that we need to be extremely careful with it.
Gradient zero, you're not going to be going anywhere. So, and not too tricky from Taylor's theorem. So it's worthwhile along the path between x and y, and then I pull quantity negative, or if I pull that over,
you'll keep coming up with objections, and then I'll keep forgetting that.
Well, that's useful.
I think it really contains the possibility of us understanding very basic things about our universe. So, how do we build a fusion reactor? How do we understand, how do we unify general relativity with quantum mechanics? These kind of basic fundamental questions about our universe, I think, have the potential to be solved with this stuff. It's incredibly powerful, but we need to be very, very careful with it.
I still need it.